So we'll learn about the new topic, that is taints and toleration. Okay, so it's possible for us to restrict scheduling of a pod on particular node. Okay, and that is achieved using taint and toleration. Okay, so taints are attributes applied to Kubernetes nodes. Okay, taints will be applied to nodes. Okay, and toleration we apply on pod level. Okay, so remember, taints are applied on the host level and toleration on the pod level. Okay, so suppose and even taints are of three types. Okay, that we can define, that no schedule nodes. If we define a taint as no schedule, okay, nodes with this taint will not accept any new pods. Okay, and if you define preferred no schedule, okay, it should avoid placing new pods on with this taint. Okay, but it will not strictly prevent it. Okay, next is no execute. If it has this no execute taint, okay, it will evict existing pods that do not have a matching toleration. So why everywhere it is said matching toleration? So if the rules are defined here, okay, but if toleration rule, okay, is defined with respect to this taints, then it can deploy it. Okay, so we'll see that in the example in a lab. Tolerations are configured within the pod specification and enables pod to tolerate specific taints. So here we'll define taints. Okay, and in case we want to ignore this taint, okay, so tolerate, that's why it's called toleration. So to ignore a specific taint, okay, we'll be using toleration. Okay, so tolerations are applied at the pod level. Okay, and taints are applied at the node level. So example use case, okay, if we have a Kubernetes cluster which has various node, okay, node A has, if no A we define taint as no schedule. Okay, no, node B will define prefer no schedule. Okay, and node C will define no execute. Okay, and will define some key and values for it. Okay, so with this with this taint, we can ensure that critical loads are scheduled only on node A. Okay, see, so if the key doesn't match, it will not schedule it. If the key matches, it will schedule it. And for node B, the use case will be prefer to avoid GPU intensive tasks. So this node B is only for GPU nodes, you can say. Okay, and automatically handle maintenance evicts on node C without manual intervention. So if anything is existing on this, it will evict it if the keys matches that. Okay, so this is what are the benefits: resource management and operational flexibility. Okay, so efficiently we can manage the utilize the road resources. Okay, similarly, operational flexibility means temporary restrictions we can add, okay, for maintenance and all, or specialized workloads. Okay, so that flexibility is provided using this. Okay, so we'll see an example here. Okay, then it will be more clear. So we have only a one node in our case. Okay, so let me first delete it. So I'm deleting kubectl, delete. So we have only one node here. In that, on that node we'll define, okay, we'll first check with this command whether the taints are there or not. So it will show none. Then we'll try to schedule something. Okay, then as that there are no tents, means there are no restrictions, so it will easily allow me to deploy the pods. Okay, then we'll do the cleanup. Okay, we are doing it with the default, that is there are no tents. Okay, now we'll apply the tent. Okay, so how the tent is applied on a particular node? kubectl tent node, the node name, and we are saying that key value should be no schedule. Okay, so when we say no schedule, it will show us the tent that no schedule, key value pair no schedule is defined here. So by default, until and unless the pod has this value, that is this toleration, to ignore it, it will not deploy any pod on that particular node. So when we try to deploy, it will be in a pending state. Okay, it will not allow because tents are defined there. Okay, then using toleration, we'll see that using toleration will define that if it tolerate it, that is ignore if the value is no schedule, and as it matches the value, it will schedule it. Okay, so this is how we achieve tents and toleration. So we'll quickly see that. So the key value is important. Until and unless it matches the key, that is toleration, it will not schedule the pods. So in this case, we have seen only one type, but there are three types. Okay, no schedule, prefer no schedule, and no execute. But we are seeing only about no schedule. So give me a minute. So everything is clean here. kubectl get all will show no pods here. Let's see the number of nodes. kubectl get nodes. Okay, so there we have one node. Let's see if any tents defined there. Okay, so here we'll see if there is any tent defined. So this is the command to get the tent details. Okay, so here saying tents equal to none. So as there are no tents, there will be no issue in deploying a deployment. Okay, it's having a deployment on it. So I'm just creating cat nginx deployment. I'll just apply kubectl apply -f nginx deployment. Okay, and again let's check. So we know that there are no tents, so kubectl get all will be, we are able to run 3 pods on it. Under the particular node, we have only one node. Okay, so by default, it will go on that node itself. Now, let's define a tent. So we created a file which was having a name without toleration. This deployment name is without toleration. If you see here, without toleration deployment. Now, let's delete that. Now we'll apply a toleration and tent, and we'll test that. So we don't have anything now. Now I'll tent the node. You should replace it with the name. So let's first check what's the name of the pod. kubectl get nodes. So we have a node with this IP. Also, let's cross check the tent. So there is no tent. I'll just tent the node. We'll need to change the name. Okay, so the name would be, so we have defined a tent that until and unless the key value doesn't match, you should not schedule anything. Now let's check tents. Okay, so we have a tent now. Now let's use the same kubectl apply. Okay, this is a deployment which doesn't have any toleration. Okay, so nothing is defined there. A simple deployment kubectl get all. So we'll see that everything will be in pending. Let's wait for a few seconds to confirm. So it will not schedule anything on it. Okay, until and unless we define the toleration. So one of the method would be to remove the toleration tent. Okay, when we remove the tent, it will schedule it. Okay, so that also we can see. So one of the method would be, if you come at the end, the command is given. So this is the command. Okay, so this we have defined here a tent. We need to change the IP here. So I'm removing tent. To remove the tent, we have this command. We just need to add key hyphen. Okay, there should, and let's add it to the IP address or the host name. Okay, so untented. Okay, there should not be any space between this key and hyphen. Now if you see get nodes tent, there are no tents, and let's check kubectl get all. It has started running. Okay, so one method is to remove the tent, but this is not what we want to achieve. We should do this only via toleration, not via uh, removing the tent. So we'll just delete and again apply the tent, and you will see how the toleration works. So let's delete all, and we'll apply the toleration again. Sorry, tent. So there are no tents. We are we have tented the node. Okay, so we have a node with this tent. Again, let's try to deploy something there. So I'll create a new deployment with toleration, and it should work even though there is a tent. So I'll apply this now. We have a tent. If you see, we have tent. We have applied this deployment. In this deployment, we have defined a toleration that when the key equals to no schedule, you should deploy it. So if you see now kubectl get all, the pods are running. Okay, so we define a tent, and only the one who has the proper key. Okay, let's ignore this. Okay, it doesn't mean no, do not schedule it. It's saying ignore this value and schedule the pods. Okay, So this was all about Taints and toleration. Hope you understood it. Okay. So if you see how it is done, so this is a image. Suppose there are three nodes. Okay, the first node is tinted with red. Okay, other one is tinted with orange, and the third node is tinted with pink. So these are the key values: tint equal to red, tint equal to orange, and t tint equal to pink. Okay, and now if this pink, okay, tries to schedule it on node 1, its toleration equal to pink. Okay, so it will not allow, it will allow only for the pink. If it is red, it is not, it will not allow on orange. If it is a pink, it will not allow for orange. Okay, so if you see the toleration equal to red and tint equal to red, then it's allowing it. Okay, here if you see the tint is orange, tint is orange and toleration is orange, then it is allowing it. Okay, so this is how it works. We can choose on which node what should be deployed. Again, tints are defined at the node level and tolerations at the pod level. Okay, so this can be an interview question.